You've reached lesson 8.5, Prisms and Cylinders. Prisms and Cylinders. Please make note of both the location, the date and time that you're watching this. Make sure you get a parent, guardian, or teacher sign-off. Last class we talked about nets, so I want you to imagine this shape being unfolded. Let's unfold it together. So I'm going to start by unfolding. Let's draw this base here. And it is a pentagon. So it's a pentagonal base. So that's our pentagonal base. And then connected to the base is 5 rectangles. So let's draw those. 1, 2, 3, 4, 5. And at the top, we have the other base. And it doesn't matter which one you hinge it to. So I'm going to hinge it here. That's going to be 1, 2, 3, 4, 5. And our goal here is to find the area, the complete area of the net. Okay, let's do the easy ones. You have 1, 2, 3, 4, 5. You have 5 rectangles. So we're going to go 5 times the length times width rectangles, which is 5 times 10 times 7, which is 5 times 70, of course. 5 times 7 is 35. Add the 0, so it's 350. Let's check for units. No units. We're going to say unit squared. That's the red. Now we have 2 bases, the blue and the green, which are exactly the same, and they're regular pentagons. So that is going to be area equals perimeter, times apothem over 2. And our perimeter here is walking around this edge. Right here, that's 10, 10, 10, 10, 10. So our perimeter is going to be 50 times the apothem we're given right there, which is 6.9. So 50 times 6.9 over 2. And then if we take this, we actually have 2 of them, so we're going to times by 2. And because of that extra 2, there's 2 of them, 1, 2. These 2's just cancel. So we're going to do 50 times 6.9. And we get 345 units squared. So my total surface area is going to be 350 plus 345. $695 units squared. And that is an example of using a net to find total surface area. Last class, we stepped into the domain of solids. Solids. The common solids we're going to talk about are prisms, pyramids, cylinders, cones, and spheres. This is our basic solid family that we're working with here. Different kinds of prisms, cylinders, which are in the same family, cones and pyramids, and then spheres. Technically, a cube is a prism. So step number 1, a prism. Basic definition of a prism and a cylinder. But that's the same family. It has 2 bases connected by rectangular faces. 2 bases connected by rectangular faces. So what I'd like you to do is we're going to pull these down into a prism. So this is going to be a rectangular base prism. So let's pull it down. Draw this with me. Okay, now watch carefully. I'm going to dot these two lines here to represent depth, because technically I can't see that corner back there if this was a solid. And this back edging, I can't see it. It's also dotted. So we use dotted lines for the unseen edging. If this was a solid, it represents depth. What we have here, this is a rectangular-based prism. Rectangular prism. Go ahead and draw that. And here would be a prism with a triangle, so let's trace that base, bring it down. Now we're going to draw a congruent triangle to represent that, but this edge back here, once again, we can't see it, so we're dotting it. So this is a triangular-based prism. It's a triangular prism. Trace that base. This is a regular pentagon. So pull this down. There's your edging that matches right here. Let's walk it around. And then these two edgings cannot be seen, so we're going to dot them. And then this last back edging also cannot be seen. This would be a pentagonal prism. And then cylinders are easy. Cylinder, you have a circle. And here we're going to draw another circle, but this back edging we dot, because once again, technically we can't see it. We pull it down, and this is a cylinder. So what constitutes a prism is this. I'd like you to shade with me, please. In a prism, you have two parallel congruent bases. Two parallel congruent bases. In a prism, you have two parallel congruent bases. Trace with me. Two parallel congruent bases. Connected by rectangular faces. Notice the rectangles connect. A rectangle connects. A rectangle connects, and technically if we were to slice this edge, this would be one long rectangle. So a prism consists of two bases connected by rectangular faces. That's a prism. And the bases can be different shapes. You can have a rectangular prism, a triangular prism, a pentagonal prism, hexagonal prism, octagonal prism, any regular polygon, and of course, technically a circular prism is called a cylinder. That is the prism and cylinder family. Now, pyramids and cones are their own family. Pyramids and cones only have one base connected to a singular vertex, which would be a point. So pyramids and cones all start just with a dot. Okay, so here we're going to connect the corners to the dot. There's 1, 2, 3, and this edge here, once again, we can't see it. It should be dotted. This is solid, this is solid. Technically, that should be dotted as well, and that should be dotted. That would be a rectangular-based pyramid, rectangular-based pyramid. Here, connect the corners. 1, 2. That back edging you can't see. That back edging you can't see. It should be dotted. Dot. and solid. This is a triangular pyramid. Triangular pyramid. Here, connect the corners, 1, 2, 3, 4, 5, 1, 2, 3, 4, and this edging cannot be seen. Technically, that edge cannot be seen as well, so we're going to dot it to represent it. That is a pentagonal pyramid. And of course, your cone, we sweep solid one way. This should be dotted back here because we're not supposed to see that. And you just pull it up right here, and there is your cone. So to recap, I'd like you to underline or highlight these words. Prisms and cylinders have two bases connected by rectangular faces. Pyramids and cones only have one base and a vertex. For this lesson, we're going to focus just on the prism and cylinder family. Students, now we're briefly going to talk about the difference between something called an oblique and a right cylinder. What you're looking right now is a right cylinder. The height and the base meet at a right angle. But if the height and the base do not meet at a right angle, that would be called an oblique. Oblique means sideways. So what you're looking right now is an oblique, and this is a right cylinder. That's oblique, meaning sideways, and a right cylinder. So coming over here in your notes, let's draw briefly a right cylinder where the height and the base meet at a right angle. So I'm going to put a little right angle here. That is a right cylinder versus an oblique cylinder, where the height and the base do not meet at a right angle. So a right cylinder the height and base meet at a right angle. The reason why it's important for this distinction is that every equation we work with over the next 20 some odd minutes only works in right cylinders and right prisms. These sideways or oblique prisms and cylinders is a different set of concepts. Now, when you have prisms and cylinders, it's very important that you understand where the bases are. The bases in the prisms are two, congruent. There's three qualities. They're congruent, parallel shapes connected by rectangles. Congruent, parallel shapes connected by rectangles. The word base does not mean bottom here. Base does not mean bottom. In prisms and cylinders, the bases are two congruent parallel shapes connected by rectangles. I always want you to get in the habit of shading and tracing the two bases. In a cylinder, the circular bases are connected by a singular long rectangle. So again, what are the qualities of the bases? They are congruent and parallel, and the bases, there's two of them, underline two, and they're connected by rectangles. Congruent, parallel, connected by rectangles. So in this shape, that green is not the base, because it is not. Base and bottom are not the same thing. In this prism, the bases These two triangles are congruent. They are congruent. They are parallel to each other, and they're connected by nothing but rectangles. So in this, I'm going to do this in pink, these triangles are the bases. They're congruent, they're parallel, they're connected by rectangles. Okay, what I'd like you to do is just take 1 minute, and I'd like you to shade and trace the bases in these prisms. Remember, there's 2 of them. They are congruent and they are parallel. You need these 3 qualities. There's 2 of them, they're congruent shapes, and they are parallel. 1 minute. Trace and shade the bases. Go. Hey! All right, let's see how we did here. Okay, so for each of these, I'm going to shade and then trace the bases. I'm going to shade the bases first in yellow. There's a base. There's a base. Those are the 2 bases. Here, connected by rectangles. This would be the front, and the back would be the bases. Because they're parallel, they're congruent, and they're connected by nothing but rectangles. Here, the circles, which are connected by 1 long rectangle. So what I'm shading right now are the 2 bases. Remember, bases, in prisms, there's 2 of them. They're congruent, they're parallel. Here I'm going to switch colors. This pink and pink. Always, always, always trace and shade the bases. Here's a tricky one. I'm going to do this in orange. Your bases are these 2 trapezoids, the left trapezoid, the right trapezoid. They are congruent, they are parallel, and they're connected by rectangles. Here, the bases are these circles. Connected, congruent, parallel, connected by a rectangle. Really critical. You can find the bases in prisms. Now what I'd like you to do is imagine a soup can. Okay, and I'm going to take that soup can and you're going to draw a diagram showing the soup can label removed from the soup can. So if you were to take that label and slice it off right here at the edge, you should recognize, if we were to pull that label off, that it would just be a rectangle. This is going to illustrate this can with this label. This would be the label, the soup label. Is going to represent what's called the lateral and surface area. Lateral and surface area. Lateral area would be the area of all the faces. This is just the faces only, or in this case, the face. So it would be the area of the label only. Whereas surface area is going to be the area of the face, or faces, which would be the label area, plus the 2 bases, which in this case would be the circles. So surface area is going to be faces plus bases. Faces plus bases. So in our soup illustration, the label is the lateral area, and it's only the area around the can. The surface area is the total aluminum can. It's all the metal. Now, this is how I'll be able to tell those who copied versus those who actually watched the video. I'd like you to take just 30 seconds and fill out on your own I want one sentence here. Explain the difference between the lateral area and the surface area in your own words. In your own words. Answer this. I'll give you another minute here. Okay, now that you know the difference between lateral area and surface area is simply the lateral area plus 2 bases. Plus 2 bases. So when it comes to how to find these, we're going to talk about lateral area and surface area. The lateral area is the area just around the side. So in this can, the lateral area is going to be the length of this edge, because that's the length of the rectangle. So this, if you look really carefully, trace it with me, that edge is the circumference. And then the distance between the bases is always called the height. So right here it says shade and trace the bases. So first thing I'm going to do is I'm going to shade the bases. There's one base. There's the other base. Let me switch colors so I can be consistent here. I'm going to use red. Shade and trace the bases. Here I'm going to, my bases are these triangles. Shade and trace the bases. Now, how to find the area of the label? If I were to peel this apart, that label, I'd end up with a rectangle, but this edge would be this edge, and that is circumference there. So how to find the lateral area in the cylinder? It'd be the circumference times the distance between the bases, which is height. Circumference times height. In any other prism, we don't call this circumference around here. We just call it perimeter of the base. So we use perimeter times height. And height is the distance between the bases. So this is going to be our height here. Perimeter times height. So lateral area of a cylinder, circumference times height. Lateral area of a prism, perimeter times height. Surface area. Remember, surface area is the lateral area plus 2 bases. So we're just going to write lateral area plus 2, and I'm going to use a capital B here. B, very important, means area of the base. Capital B means area of the base. Lateral area plus 2 bases. For a prism, it's also lateral area plus 2. We use a capital B here. B means area of the base. And pause and let you write that down. It is really important. This B can be any of these B shapes right here. This B could be, it could be an area of a triangle, a circle, regular pentagon. You need to be very flexible with what that B stands for. Now, these problems seem like there are a lot of steps, but if you just get this little chant stuck in your head, you won't get lost. So I'm going to say this several times. After you hear it the first time, start chanting with me. The 6 steps are, there's 1, 2, 3, 4, 5, 6. Label those, 1, 2, 3, 4, 5, 6. The 6 steps to dealing with solids goes like this. Shade, trace, perimeter, base, equations, circle, plug, chug. Say it with me. Shade, trace, perimeter, base, equations, circle, plug, chug. Shade, trace, perimeter, base, equations, circle, plug, chug. Again. Shade, trace, perimeter, base, equations, circle, plug, chug. One more time. Shade, trace, perimeter, base, equations, circle, plug, chug. Just once more for kicks. Clap with me. Shade, trace, perimeter, base, equations, circle, plug, chug. Those are the 6 steps that we're going to walk through. If you follow these 6 steps, you will not get lost. Failure to follow these 6 steps, it is very easy to get lost because these are very complex problems. Ready? Okay, let's do these steps together for this one problem. Okay, step number 1, we want to shade and trace the bases. Shade and trace the bases. Remember the 3 qualities of the bases? There's 2 of them. They're congruent and they're parallel. There's 2 shapes, they're congruent and they're parallel. So here, my bases are going to be here and here. Shade and trace the bases. Shade, trace, shade, trace the bases. That's step 1 and 2. Check. Shade, trace, perimeter, base, equations, circle, plug, chug. Shade, trace. Now we're going to find the perimeter. So we're going to, and when it says perimeter, it's always perimeter of the base. So let's walk our pencil around. Put your pencil right there. Ready? Trace with me around the edge here of the base. That's 7. Keep going. That's 24. Keep going. Whoops. We don't know that. We need that to get our perimeter here. So let's draw it. That's 7. It's 24. That's X. We need that to get our perimeter. You should recognize that this is a right triangle. 2 sides of a right triangle, 3rd side. Write out the equation. Leg squared plus leg squared equals hypo squared. This is actually a triplet. Ready? 7 squared plus 24 squared equals unknown squared. What we're going to end up with is X is the square root of 24 squared plus 7 squared. So I'm going to go 24 squared plus 7 squared equals, I get 625, and then I square root, and I get 25. So in the margin here, our perimeter, use a capital P, our perimeter, we're going to, now we can have it. So trace with me, we're going to add it together. Ready? Pencil here. Let's add 7 plus 24 plus 25. 7 plus 24 plus 25. And we get our perimeter is 56. And we don't have any units here, so we're just going to say units. We're halfway through. Shade, trace, perimeter, base. When it says base, it means find the area of the base. So now we have to find the area of the base. And we have a right triangle. In the area equation, area equals leg times leg over 2. We have here one leg is 7 times the other leg is 24 over 2. We're going to end up with 7 times 12. That's 12. 7 times 12. That's 70 plus, that's 84 units squared. So now we do this. We write B. We're going to use capital B, which means area of the base is 84 units squared. I would like you to box these answers. You're going to need them. There's your perimeter. There's your base. We're 3/4 of the way there. Shade, trace, perimeter, base. Shade, trace, perimeter, base. We're right here. Shade, trace, perimeter, base. Now we want to find the lateral area and the surface area. Our lateral area is perimeter times height. That's right here. Whoop, right there. And our surface area is whatever our lateral area is plus the area of 2 bases. Capital B for area of. Okay, ready? Now we circle, plug, chug. Circle, perimeter. We have the perimeter already. So we're going to bring it down here. It's 56. Height is distance between the bases. Our height here is 28. So we do 56 times 28. And we get 1,568. So we write lateral area equals 1,568 units squared. That would be the area around the sides. Now let's do the one on the right. Ready? Lateral area we already have. It's right there. Circle, plug, chug. 1,568. Plus the area of 2, notice capital B, we have it, it's 84 units squared. That's our 2 bases. So we're going to go 84 times 2, and then we're going to add 1,568. We get 1,736. Our surface area is 1,736 units squared. That's how you do lateral area and surface area. Lateral area and surface area. We're going to follow shade, trace, perimeter, base, equations. Circle, plug, chug. You've been sitting for a half an hour. I highly recommend you take a 1-minute stretch break for the last about 10-15 minutes of this video. So I'm going to set the timer. I actually want you to take a 1-minute stretch break. Ready? Stretch, stand, take a deep breath. Nice giant cat stretch, go. All right, let's do this problem together. We're going to do it together even though it says it's your practice. So shade and trace the bases. So we're going to shade the base, which is a circle and another circle. Shade, trace. Shade, trace. Okay, we're done with the first two steps, shade and trace. Now we're going to find the perimeter, but in this case, perimeter is circumference. So we know C equals d pi. And in this case, trace the diameter. Don't pick up with your eyeballs. Pick up with your pencil. Trace it. You should feel that your diameter there is not 4. You have to double it. It's 8. So our circumference is 8 pi. So put this in the margin. You're going to need it. Your circumference is 8 pi. It's just units. Box that. You're going to need it. Shade, trace, perimeter, base. Now we're going to find the area of the base. Area equals pi r squared. In this case, it's pi 4 squared, 4 being the radius. So our area is 16 pi units squared. So we're going to call it, remember, area is now going to be a capital B, meaning area of the base. So our B here is 16 pi units squared. Box that. We're going to need it. Shade, trace, perimeter, base, equations, circle, plug, chug. Our equations for a cylinder for a lateral area is circumference times the height. Surface area is whatever the lateral area is plus the area of two bases. Follow with me. Shade, trace, perimeter, base, equations, circle, plug, chug. Circle, circumference. Come up here, pick up circumference. Circumference is 8 pi. Height, distance between the bases. Our height is 12. So we're going to simply do 8 times 12. That's going to be 80 plus 16, 96 pi. So it's 96 pi units squared. That would be the area, what's called lateral area. That'd be like the area of the label. Okay. Now surface area, that's LA equals. Surface area is the lateral area, so we're going to bring this over. So we have 96 pi plus 2 bases, which we pick it up, is 16 pi. 2 times 16, I have 96 pi plus 32 pi. You have 96 and 32 right here in the margin. That's 8, and that's 12. Your final answer for the surface area is 128 pi units squared. Shade, trace, perimeter, base, equations, circle, plug, chug. Now to keep this straight, surface area is like the wrapping paper. On a gift. So surface area, total surface area would be like the wrapping paper of a gift. Volume, it measures, okay, surface area measures the overall area of the solid. Okay, volume is like the stuff inside. It's the gift itself. So whatever's inside the box, we would call that volume. Now the equation for volume is really easy. Take a look at this animation here. To find volume, all you do is you start by finding the area of a base. Whatever it is, you can find the area of the base. Doesn't matter what that area is. Okay, so this case would be a triangle. You'd find the area of a triangle. So you find the area of the base, and then to get the stuff on the inside, you simply times it by the height. So once again, volume is simply area of the base, and then you add the dimension of height. So the volume of any prism and cylinder is simply the area of a base times the height. And remember, height is the distance between the bases. So we write it like this. It's the area of the base. We use a capital B for area of the base times height. Area of the base times height. That's volume. Seems a little bit easier than all that area stuff. We're going to follow the same 6 steps: shade, trace, perimeter, base, equations, circle, plug, chug. So we're going to shade and trace the bases. Our bases are these two. 1, 2. Shade, trace the bases. There's your 2 bases. Check. Now we want to find the area of the base. And remember, this base in this case is a right triangle. So we write our equation here, which is area of that base is leg times leg over 2. Write that down. So one leg is 7. The other leg is 24 over 2. That's going to end up being 7 times 12. And we get 84 units squared is our base. So we write here, base equals 84 units squared. Now let's write the equation here for a volume of a prism, which is simply base times height. Now, we circle, plug, chug. Our base, we have it already. It's 84. Height. Height there's not 7. Height is the distance between, here's your bases, it's the distance between the bases. So height here is going to be 28. This is for volume. So our volume here, we simply do the area of the base, which is 84, times the height, 28, 2352. Units now cubed, because we're now in the 3rd dimension. This is a little overwhelming the first time you do this. Don't panic. You're going to get better at it as we do this. We're going to do one more problem together. Just one more problem. I'm going to work it through with you. Okay? I'm not going to leave you on your own this time. We're doing the 6 steps. Shade, trace, perimeter, base, equations, circle, plug, chug. And walk through these steps here. Step number 1, we're going to shade our bases. In this case, the base is the front and back circle. Shade, and then we're going to trace the bases. So there's one, and then of course there's the other. Shade and trace the bases. Check. Now we want to find shade, trace, perimeter. Now in this case our perimeter is circumference, so we write the equation, C equals D pi. Circle, plug, chug. D, physically pick up the D, trace it all the way. We already have it. It's 22 pi. So in the margin, write C equals 22 pi units. Box that so it's easy to find. Shade, trace, perimeter, base. Base, we want to find area of. This case, the area is a circle. Let's circle, plug, chug. Radius. Physically pick up the radius. Now be careful there. The radius is not 22. The radius is half of 22, which is 11. So we're going to go 11 squared times pi. 11 times 11, you should have that memorized, is 121 pi. So put this in the margin. The area of our base, use a capital B, meaning area of one base is 121 pi, and we do have units this time, inches squared. Box it. Shade, trace, perimeter, base, equations. Circle, plug, chug. Now we're going to write down our equations for lateral area, surface area, and volume of a cylinder. Lateral area is circumference times height. Surface area is whatever the lateral area is plus 2 bases. Use a capital B for area of the base. Volume is area of the base times the height. Take a moment, write all three down. Ready? Now we're going to circle, plug, jug. Circle, circumference, we already have it. Circumference is 22 pi times height, distance between the bases, 10. So we have here our lateral area equals 10 times 22, which is 220 pi inches squared. That's our lateral area. Surface area is the lateral area. So circle, circle, plug it in. We have 220 pi plus 2. Circle that B. Pick up the B. 121 pi. So we're going to double 121. So we have 220 pi plus, just imagine another 121 here. That's 2, that's 4, that's 2. 242 pi. So 220 plus 242, we get 462. So our surface area is 462 pi inches squared. That's our surface area. Volume is simply base times height. So our volume, we circle base, pick it up. Our base, 121 pi, times height, which is the distance between the bases, which is 10. So we're doing 10 times 121. So of course volume, you just tack a 0, 1210 pi, and now it's inches cubed. Seems like a lot of work, but once again, if you just keep these 6 steps in mind, you won't get lost. Those 6 steps are the same 6 steps. Shade, trace, perimeter, base, equations, circle, plug, chug. Now when it talks about equations, these are the equations. You absolutely have to have this memorized. There's no way around this. You have to have this memorized. You've been given a memorization sheet with several pages of practice. It is critical that you take the time to practice and to memorize these equations. Both the equations from all our area equations, these are all our area equations we just learned, and here is what you learned today.